Hello, welcome back. Working with SFML again. SFML in the C programming language. Last time we did this. We're going to build on this and create some walking. Create a walking sprite of sorts. And it should go even more smoothly this time because I have printed out the necessary code. I've already worked out exactly what we need to do. Oh yes, first off, I'm going to change this to SF close to and make this bigger. There you go. Maybe. We're also going to set the background color of the window to something other than black or white. I set it to a nice little dark gray. Color underscore from RGB. 64, 64, 64. We're going to use that later. So the sprites, we're going to be using these two sprites. They're both 36 by 64, so we're going to need to change this. Wait a minute. Yeah. 36, 64. And there's two of them, so we're going to do texture left, texture right. File name is PC-0-L for the left one. That stands for player character number 0 left, by the way. And this is taken from a stand-in that I originally used for Crutch Chaos, which, if you've seen my older videos, you've seen that. Take that, copy it, change it for the right one, C0R. And then I'm going to do player sprite, texture right, and we are not going to use the mouse for this. Instead, we're going to use the keyboard. But first, we're going to we're going to create player data. We're going to use a struct for that. Struct player, if I can spell right. Actually, yeah. We're going to do a vector2f, a two-dimensional floating point vector called position that will hold the player's position, that will have x and y components. We're going to do have the width of the player, the height of the player, and the speed of the player. We're going to instantiate this as player 1. Then we're going to set these parameters that we just set. Player 1 dot position dot x equals 128. We'll do the same value for y. Player 1 dot width equals 36. Player 1 dot height equals 64. And player 1 dot speed equals 300. Now that may seem high, but it's actually kind of slow. It's going to be used to multiply with something else that is going to be introduced here. Specifically, we don't need this code because the window can't be resized anymore. We don't need this code because the mouse is not going to move. Alright. What we do need is to set up to keep track of time since the last frame. This is something that a lot of engines will do for you, and this is one of the things that kind of makes this not a true engine in some ways. So we're going to create a clock. Let's finish typing the comment first. Prepare to track time since the last frame. Do SF clock. I don't have clock open anymore, but here's time, which works with clock. SF clock pointer. I'm going to call it hourglass because that's a nice name for timekeeper. Equals SF clock underscore create. And we're going to set the time. We're going to create a time variable. I'm going to call it delta time and set it to SF time 0, which is just 0 time. And then at the start of each frame, the start of each game loop, which is equal to each frame, we are going to set that delta time equals SF clock underscore restart. That will restart the clock and return the amount that the clock had counted up to before it was restarted. So each time this runs, it's going to be a certain amount of time, a certain fraction of a second. And we're going to use that to multiply by things currently in movement to scale them to the speed of the program and the speed of the computer, so that on a faster computer or a computer with less stuff going on, things don't run ultra fast, and slow computers don't make things go all choppy and weird. The clock restarts, and I do believe hourglass, right? It needs to give the clock to restart. And that delta time, or DT, or delta, whatever your engine calls it, is a very important little piece of data. So we're going to add to the events here. Else if event.type equals SF EVT key pressed. It's right in here. EVT key pressed, and funnily enough, the very first struct shows you what is in that. It says key data is an event.key. This is the data that it will have. So we're going to want, for the actual key, we're going to want event.key.code. That will come up in a moment. But right now we're going to check if event is key pressed, and if so, we're going to check if event.key.code equals SF key left, which is the left arrow key. And if it is, move sprite, move player left. I'm going to do SF sprite underscore set texture. We're going to reset the texture on the player sprite based on if they're facing left or right. So set player sprite texture right and true to reset, and then we're going to want to move it player1 dot position dot x, and we could do equals player1 dot position dot x minus whatever, but there's a handy little shortcut. You can do minus equals, and that's the same as typing x equals x minus something. And if you have to do a lot of a equals a minus something or a equals a plus something in a program, it can save you a lot of typing. That's the thing a lot of C-like programming languages have. So player1 position dot x minus equals SF time, and we're going to want to do the underscore as seconds function. You could do as milliseconds or as microseconds as listed here. You know what? I want to reopen clock. It's a very simple, pretty simple little module. Just gets time, restarts, yeah. Set time as seconds, and it's delta time. And then we're going to want to multiply that by the speed. Player1 dot speed, and then multiply that by, oh no, we already multiplied by delta time, that's right. You can't directly multiply by delta time even though it's supposed to sort of be a number, because it's stored as this SF time thing. You need to pass it through one of these seconds, SF time as one of these functions, SF time as seconds or milliseconds or microseconds, to get a nice floating point number that you can add and subtract and do other mathematical functions on. Semicolon, do else if event dot key dot code equals SF key write. Yes. And then it's basically the same code. So let's copy and change and move player right. If I can type right. Okay, this was supposed to move left. So change that to left. But this is the correct equation, if you want to call it that. Because x left is this way, or on camera, left is this way, negative values are this way. Right being this way, positive values are this way. So when you subtract, you go this way. When you add, you go this way. And then for the y-axis, normally, although some engines have it the other way around, up is of course this way, down is this way. So positive values are this way, and negative values are this way. So you add, you go down. You subtract, you go up. And that is something that can really trip you up even after years of working with engines, but that's another story. And it's something we will look at most likely in the next video. So change this to plus equals because we're adding. Close that, get that closed bracket. And yes, after all this, we're going to want to set the player's position. Sprite for set position player sprite to player1 dot position, and that's part of why I stored that as a SF vector 2f, because that's what SF Sprite takes in. And then we just need to change this sprite, this line to player sprite, and then why not destroy the sprite when we're done? So sprite underscore destroy. of Sprite or destroy player Sprite. Clean up memory. Although that doesn't, again, that doesn't delete things from memory. But I assume it helps in some way. I don't, it's in there for a reason. I know it's in there for a reason. And it seems to be good practice to do it. So, might as well. So we're going to compile. Please see the previous two videos for tips on compiling all this. That compile string doesn't look long enough. See, I've got the path to the compiler, the C file, the library, the precompiled header folder. It has the actual code, list of libraries. I've got the include, so the headers like these that just have prototypes for functions and structs and things. And then the output. Yeah, that should be good. So I've just given you another overview. Texture create from file. It's not too happy about that. txrect. It's not happy about that either. Yeah, it created an executable, so let's run it. Yep, and you see I press the keys and he walks. You will notice he is not on anything. That is because we did not create and place any sprites for the player to be on. You can also walk off the screen, which is a little, yeah. And you know, we can go ahead and fix that right now. We can run this, run the movement if player1.position.x is greater than 0. And run this if, oh, that needs to be in parentheses. What is this, Lisp? If player1.position.x is supposed to be greater than 0. Player1.position.x is less than, I'm not sure of a quick, easy way to get the width of the window. I'm sure there is one. But we're just going to, right now, we're just going to do a magic number 480 because we know, or 640, because it's 640 pixels wide, minus player.width, because we've got the edge of the window over here, and then the actual coordinates of the player are X number of pixels over, because it's at this corner of the player. It's at this corner of the player, this corner right here. Recompile that. Player1.width. Dink. Going over there and do. Oh, didn't stop him. Oh well. And you will notice now there is no resize thing when I go over here. I can't maximize it. That was the effect of changing this to SF close. Oh yes, I didn't change the background color. That's a very simple, quick change. I think this looks better. Dink. Alright. And that is going to be it for tonight. I hope you found something useful. I should be back next time with more on SFML. Not sure how much longer, but I'm planning on one more video at least. I'll be seeing you.